Question 20. A scientist is studying the growth of bacteria. The scientist models the number of bacteria, n, by the equation n of t equals 200 times e to the power of 0.013 t, where t is the number of hours after starting the experiment. Part A. What is the initial number of bacteria in the experiment? The word initial implies the time t equals 0, that is the time at the start of the experiment. Substituting t equals 0 into the equation, we have n of 0 is equal to 200 times e to the power of 0.013 times 0, which is 0 here, and e to the power of 0 is equal to 1. So 200 times 1 is equal to 200. So the initial number of bacteria in the experiment is 200. Part B. What is the number of bacteria 24 hours after starting the experiment? Substituting t equals 24 into the equation, we have n of 24 is equal to 200 times e to the power of 0.013 times 24, which evaluates to 273.23 and so on, which rounds to approximately 273 bacteria, correct to the nearest whole number. Part C. What is the rate of increase in the number of bacteria 24 hours after starting the experiment? The instantaneous rate of increase in the number of bacteria is given by the first derivative n dash of t or dn dt. Now recall that the first derivative with respect to t of the exponential function a e to the power of kt, where a and k are constants, is given by a times k times e to the power of kt. And in this case, a is equal to 200 and k is equal to 0.013. So n dash of t is equal to 200 times 0.013 times e to the power of 0.013t. Let t equal 24 to find the instantaneous rate of increase at 24 hours after the start of the experiment. So n dash of 24 is equal to 200 times 0.013 times e to the power of 0.013 times 24. Evaluating this expression, that equals 3.522 bacteria per hour, correct to 3 decimal places.